So we all know it's pretty easy to cook an expensive cut of beef like tenderloin. As the name suggests, the meat is already tender. All you have to do is cook it to the right temperature, and it's going to be pretty great. But what if you start with something a little tougher, something inexpensive like this boneless eye-round roast? Now, cooking this meat to a precise temperature is going to ensure that you get a medium rare roast, but that's not going to make the roast tender. For that, you need some help. So, why are some cuts of meat naturally tender and others tough? Well, let's review some of the basics. Meat, whether it comes from a cow, a pig, or lamb, consists primarily of muscle fibers, connective tissue, fat, and water. Those are the four ingredients. Now, each muscle contains thousands and thousands of individual fibers. These fibers are very fine. They're actually thinner than the average human hair, and they're several inches long. Individual fibers are bundled together and wrapped in something called connective tissue. The structure isn't all that different from this electrical cord, with the individual fibers, which are the muscle fibers, wrapped in a sheath, and this is the connective tissue. Now, these bundles of wrapped muscle fibers are visible as the grain in many cuts, including, for instance, this flank steak. So the connective tissue is a translucent film that surrounds the muscle fibers, which are made of protein, gives the muscle fibers some structure and support. It also attaches the muscles to the bone. So when you're cutting into a roast like this tenderloin here, you can actually see the thin silvery film. We call this silver skin, and it's really tough. So the main protein in connective tissue is something called collagen. It's very sturdy and it's tough to chew. Cuts from muscles that aren't used for mobility have very little of this connective tissue, that is collagen, so they're naturally tender. Now this is something like what was in the tenderloin here, from the middle of the animal. It doesn't get a lot of use. Cuts that come from muscles that are heavily used, like those from the shoulder, such as a chuck roast, or the hip roast, which we call the eye-round roast, which comes from the round, have a lot of connective tissue, so they're pretty tough. Okay, so we've talked about muscle fibers and connective tissue, but what about the two other components in meat, fat and water? There are actually two kinds of fat. There's intermuscular and intramuscular. Intermuscular fat is the thick fat layer that separates various muscles. This fat is often trimmed away. You can see it here in this ribeye. The other kind of fat is intramuscular fat. It's the thin filaments of fat that run throughout a cut. This is often referred to as marbling, and it's a key factor in determining flavor and perceived juiciness. You can see that here in this ribeye as these thin white lines within the muscle itself. As meat cooks, the intramuscular fat melts, making the meat seem juicier and easier to chew. Okay, so I've saved the most abundant component for last, and that's water. Now, believe it or not, cuts of meat contain about 75% water. It makes meat juicy, but not tender. The higher the internal temperature of the meat, that is, the more you cook it, the more water that gets expelled as the muscle fibers contract, and you end up with drier meat. Now here I have 3 ribeye steaks that I've cooked and then cut in half. I've cooked them to different temperatures. So this first one here, I cooked to rare, with a final internal temperature after resting of 125 degrees. This middle one here, I cooked to medium, with a final internal temp after resting of about 140 degrees. And then finally I have a steak that is well done, which is 160 degrees. Now I also have this raw ribeye over here. Now look how much the texture changes as the meat cooks. Here, it's very soft and easy to press. If I move over to my rare steak, it's again very easy to compress with my finger. Now as I go up to the medium, it's much firmer, and finally the well done steak is extremely firm. So as the muscle fibers heat up, the linear protein molecules begin to chemically bond with each other, causing them to compress and contract. A single muscle fiber can shrink to as little as half its original volume during cooking. So this contraction, just like a sponge, squeezes out some of the liquid trapped within the proteins. This transformation is what makes it possible for experienced chefs to judge the doneness of a steak simply by pressing on it and feeling how firm it is. However, checking a steak's doneness by texture alone is a really inexact science. It takes a lot of practice to get right. So what we really recommend here in the test kitchen is a super fast digital instant read thermometer. So something like this ThermaPen by ThermaWorks gives you a readout in 2 to 3 seconds. And what you want to do is make sure that you insert the thermometer into the thickest part of the meat, with the tip of the thermometer centered in the roast. This is going to give you the best reading. So cooking to an exact temperature guarantees perfectly cooked meat every time. But if you do wish to practice the pressing technique, Here's how to do it. So press the steak. You're going to compare that with the texture of your hand. You want to feel the fleshy part between your thumb and index finger. Now that kind of soft, squishy feeling approximates rare meat. Now make a loose fist. Do the same thing, and this is going to approximate the feel of a medium steak. Finally, touch the tip of your nose for well done. In addition to the muscle fibers becoming more taut at higher temperatures, the steak is also losing moisture. Now this well done steak lost twice as much liquid during cooking as this rare steak. Most of this weight loss is moisture, along with some rendered fat. So in addition to being firmer and tougher, a well done steak will actually be drier as well. In addition to the muscle fibers becoming more taut at higher temperatures, the steak is also losing weight. Now this well done steak lost twice as much weight during cooking as the rare steak. Most of this weight loss is moisture. There's a little bit of rendered fat as well. But so in addition to becoming firmer and tougher to chew, a well done steak will also be drier. The classic way to break down connective tissue is through prolonged cooking, such as barbecuing or braising. In these slow and low cooking methods, the meat is cooked beyond well done, and it's held there for a long period of time. Now the important thing to understand is that collagen breakdown is dependent upon both time and temperature. So these methods do a good job of making a tough cut tender. Note that collagen breakdown in this scenario is happening in earnest at temperatures above 160 degrees. But what if you don't want a well done roast? You want a cheap cut, but you want it medium rare. That is, with the meat cooked to an internal temperature of about 130 degrees at serving time. In the test kitchen, we solved this problem through a combination of overnight salting and low temperature roasting. Now, here I'm going to focus on the low temperature roasting because salting will be covered in depth in another lesson. But in short, sprinkling the meat with salt, and we prefer the coarse crystals of kosher salt, does two things. One, it obviously seasons the meat really well. More important for our purposes, it also helps to dissolve some of the proteins in the connective tissue, which makes things a little bit tender. Now for a 4-pound roast, we season on all sides with 4 teaspoons of kosher salt. Then we wrap it in plastic wrap and refrigerate it for 18 to 24 hours. So this roast here was salted, wrapped in plastic, and it sat in the fridge for about 24 hours. Now all I have to do is unwrap it. I'm going to blot it dry. Now this is an important step. If I left the moisture on the surface of the meat, it would greatly inhibit browning. And keep the surface of the meat about 212, which is the boiling point of water. And I need it to go much higher to initiate the Maillard reaction and some caramelization. Really get that flavorful crust we want. Since I'm going to cook this roast at a very low temperature, I'm first going to sear it on the stove top. So now I'm rubbing it with 2 teaspoons of vegetable oil. And this is going to help conduct the heat to the meat while we're searing. I'm also going to season it with 2 teaspoons of ground black pepper. This is obviously for flavor. I'm seasoning from nice and high so I get a really good even distribution of the pepper on the meat. If you season too close, you end up with clumps, and those will be harsh tasting. All right, that looks great. Now I'm first going to sear it on the stovetop to produce that flavorful crust I was talking about. The really high heat of my skillet will initiate the Maillard reaction on the surface, so we get a nice brown color, but it'll be very quick, so I don't have to worry about overcooking the meat below the surface. Now I've started to heat a tablespoon of vegetable oil in a 12-inch traditional skillet just here. Now I'm going to heat it until it just starts to smoke, which it's starting to do right now. And that's a really good indicator that my pan is very hot. For this kind of refined oil, it's in the range of 450 degrees. So I'm going to sear the roast all over, turning it occasionally with tongs to ensure even browning. This is going to take about 12 minutes. Okay, so now that my roast is well browned on all sides, I'm going to transfer it to a wire rack set in a rimmed baking sheet. And turn off the heat. So the wire rack here is actually really important. What it does is it elevates the meat off the baking sheet. It allows for even air and heat circulation. So at this point, the roast is going to go into a really low oven, 225 degrees, for an hour and a quarter to an hour and 3/4. I'm going to gently cook the roast this way until the internal temperature registers 115 degrees. Now obviously that's lower than we want the final temperature to be. At that point, I'm going to turn the oven off. I'm going to let the internal temperature, again taken in the thickest part of the roast, to slowly climb to 130 degrees, which is going to take another 30 to 50 minutes. Finally, I'll transfer the roast to a cutting board and let it rest for 15 minutes before slicing. So why do we use such an odd cooking method for this roast? Well, I'll explain. Now, I'm sure many of you have eaten a dry-aged steak at a high-end restaurant. Besides being more flavorful, meat that has been stored in a humid refrigerator for up to about 30 days is incredibly tender. Why? Well, the simple answer is enzymes. Enzymes are a type of protein. In living animals, one of the functions of enzymes is the turnover and reprocessing of other proteins around them. So in meat, these enzymes are still active. They continue to increase the rate of chemical reactions, which can greatly affect the consistency, texture, and color of meat. Here there are two really important enzymes, calpains and cathepsins. Calpains break down the proteins that hold muscle fibers in place within an actual muscle. Cathepsins break apart a range of meat proteins. They can even weaken the collagen, that really tough connective tissue. Now, to make things a little more tangible, we can think of these enzymes as little saws or even little scissors. They're physically breaking down muscle proteins. So it's something like using this pair of shears on these muscle fibers. It goes in, and it just clips a few of them. And what it's doing is basically tenderizing that piece of meat. Now, those cathepsins would also go and clip some of this tough connective tissue, which is made up of collagen. Again, making the entire thing a lot more tender. So the activity of these enzymes is largely based on temperature. The rate at which they break down protein in a cut of meat held at refrigerator temperatures is actually fairly slow. Now, this is the reason that you need about 30 days of dry aging to see a real impact. But the rate becomes much faster as the temperature of the meat increases, right until it reaches 122 degrees, when everything comes to a halt. So, by slowly heating our roast in a low oven and then turning the oven off before the meat reaches 122 degrees and stops, we allow cathepsins to work in overdrive. We get the tenderizing effect of aging in hours instead of weeks. In contrast to the slow cooking methods that we talked about before, such as braising and barbecuing, those are really tough cuts of meat. This technique is best used for cuts with a moderate amount of connective tissue, ones ideally cooked to no further than medium. Now, we didn't just rely on tasters here in the kitchen to verify that our salting and low temperature method was working. We really put it to the test. We ran a kind of crazy experiment to show what happens at the extremes. So we cut one rib roast into 2 equal steaks. We cooked one in a 120 degree water bath for 48 hours. We cooked the second steak in that same water bath, but just until its internal temperature hit 120 degrees, which took about 2 hours. Now we're using 120 degrees because we don't want to go over that 122 limit. We want the enzymes to be working in overdrive. We then cut 1/4 inch thick, 4 inch long cross-grained slices from the same part of each steak. Now it's a piece that looks just like this. Now to the other end of the steak, we've tied with kitchen twine a 2-pound lead weight. I have the exact same setup that we've used in extensive testing here in the kitchen, and I'm going to demonstrate it for you now. So this one here is the steak that cooked for about 2 hours until it reached 120 degrees. This one here cooked for 48 hours at 120 degrees. What I'm going to do is with tongs, I'm going to lift them both up at the same time. I'm going to hold them. We're going to see which one supports the weight for longer. All right, so here we go. Get a nice grip on both. Okay, and I'll go up on 3. 1, 2, 3. Okay, so that happened pretty quickly. So as you can see, the steak that was cooked for 48 hours at 120 degrees tore almost immediately, while the one that just came up to 120 degrees was pretty resilient. I don't know how long that would hold, but a lot longer than the long-cooked one. So it becomes very clear in this instance that internal temperature isn't the only factor in determining tenderness in meat. Both of these were cooked to exactly 120 degrees. But in the 48-hour sample, the enzymes had much more time to work their magic, which is why that meat is so tender. But how do we know that the collagen breakdown was a product of this enzymatic activity and not heat, as in a braise. Well, heat-induced collagen breakdown doesn't take place until 140 degrees, and even then it happens at a very slow rate. Now, I'm not suggesting that home cooks go out and spend 2 days trying to cook a steak. This experiment illustrates the extremes to prove a point. Even an hour of intense enzymatic activity, which is best achieved by slow roasting in a low-temperature oven, can make a big difference. Now, there's one more benefit to slow roasting this way, and this one is really easy to see. Here's the same roast cooked to the same internal temperature at its center, which is 130 degrees. But this roast was cooked in a 400-degree oven. Now, as you can see, by the time the center came up to 130 degrees, most of the meat around it reached temperatures well above that, and that meat is well done. So now, let's slice into the roast cooked by our method, in a 225-degree oven, and then in a turned-off oven. And when you're slicing any roast, and it's particularly important with a tough one like this, you always want to cut across the grain. And what you're doing when you cut across the grain is that you're slicing through long muscle fibers. You're shortening them. You're making them easier to chew. Likewise, thin pieces will increase perceived tenderness. I'm going to go ahead and slice this one up. Now, as you can see, this roast is medium rare, nearly from edge to edge. There's a little bit of overdone meat from when we're searing it. But here we have meat that is perfectly cooked, and not just at its very center. All right, let's try this. Really nice beefy flavor, and it's remarkably tender for an eye-round roast. So using a low-temperature oven to roast is good for many cuts. It's not just tough ones like this. Even prime rib does better. We found here in the test kitchen that a prime rib, one of the most expensive cuts, cooked in a 250-degree oven, lost about 9% of its moisture. It emerged incredibly juicy from the oven. The same roast, cooked in a 450-degree oven, lost 24% of its moisture. That additional moisture loss means drier meat. So, whether relying on the saw-like action of enzymes to weaken collagen, identifying and hitting the perfect internal temperature with a fast digital thermometer, or slicing a roast thinly across its grain, you now understand some invaluable ways to control meat texture right in your home kitchen.